nebula, a pre-solar nebula, meaning before the sun was a thing and before the planets were a thing. So in 1951, this guy pointed out that large numbers of icy bodies condensed in the cold outer parts of the pre-solar nebula. Although many of those bodies were scattered by the gravitational influence of Neptune and the other Jovian planets, Kuiper predicted that some of the icy bodies should still remain in a circular ring beyond the orbits of Neptune and Pluto. As a consequence, the region close to the ecliptic plane at distances from around 30 astronomical units to 50 astronomical units from the sun is called the Kuiper Belt. Yay! Thank you for liking the live. Can we get 20 likes? Thank you, thank you, thank you. Can we get 20 likes? Thank you, thank you, thank you. Small bodies beyond the orbit of Neptune are faint and thus difficult to detect. So yeah, if we can try to image these things, but they're so far, it's going to be faint. The first trans-Neptunian object other than Pluto and Charon was detected in 1992. So as recent as 92. The object named 1992 QB1 is on an orbit with a semi-major axis of 43.7 astronomical units, an eccentricity of 0.065, and an inclination of 2.2 degrees. Thank you for liking. Thereafter, TNOs, or trans-Neptunian objects, were discovered at an increasing rate. Over 1,000 TNOs were detected in the 15 years that followed the discovery of 1992 QB1. So remember, for the longest time, Pluto was the 9th planet, but then now we've discovered a lot of these trans-Neptunian objects. The orbital parameters of the known trans-Neptunian objects are going to be plotted here. See, we will look at this in just a second. The upper panel shows orbital inclination I as a function of semi-major axis A. The lower panel shows orbital eccentricity E as a function of A. We will look at this. Uranus is the large dot. We will see this dot, and a semi-major axis of 19.2 astronomical units and a low inclination and eccentricity. Neptune is the large dot at 30 astronomical units for the semi-major axis and low inclination and eccentricity as well. We also have a number of objects with orbits smaller than that of Neptune in this figure. These objects, which lie outside the orbit of Jupiter but inside that of Neptune. So there is a name for objects that lie outside the orbit of Jupiter, so outside of 5.2 astronomical units, but inside that of Neptune, and these are called centaurs. It's kind of like Harry Potter, centaurs. This is because the first such object discovered was given the name Chiron. Oh, I think Chiron is pretty important in astrology as well. So the first such object discovered was named Chiron, Chiron, after the most famous of the mythological centaurs. Most of the trans-Neptunian objects have a semi-major axis that place them in a narrow, classic Kuiper belt, with the semi-major axis basically lying between 35 and 50 astronomical units. Most inclinations are relatively small, with the majority of TNOs having an inclination less than 10 degrees. But this is partly a selection effect. The early searches for trans-Neptunian objects concentrated on the region near the ecliptic. Concentrated on a region near the ecliptic. Eccentricities have a fairly wide range, with E being between 0 and 0.3, but a few have higher eccentricity. Notice that there is a large excess of TNOs with a semi-major axis of 39.5 astronomical units, similar to the semi-major axis of Pluto's orbit, right? Pluto was found at around 39 astronomical units. These objects called Plutinos. So now we have Plutinos, Plutinos. Chiron is spelled Chiron, Chiron. But now we have these Plutinos, little Plutos, after their prototype, are all in a 3-to-2 orbital resonance with the planet Neptune. Remember, that's how Pluto was too. In addition, there is a smaller but still significant excess of TNOs with a semi-major axis of 47.8 astronomical units. So we're kind of just finding all kinds of things that are sort of beyond Jupiter, and also some of them are beyond